Hello everyone. Welcome back to Dr. Lou's VCE Physics channel. Today, let's learn together about the 2023 physics examination. We will focus on questions related to the generation and transmission of electricity. My explanations may be flawed. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. Ask for the peak-to-peak voltage and the frequency. One vertical division represents 20 V, so the peak-to-peak voltage is 120 V. One horizontal division represents 10 milliseconds, so the period is 40 ms. The frequency is reciprocal of the period and is 25 Hz. Finally, D is correct. A transformer provides a low voltage for globes. The input voltage of the transformer is 240 V, and the globe is 12 V. The power of each globe is 20 W. The ratio of primary voltage to secondary voltage is equal to the ratio of primary turns to secondary turns. We know the primary voltage and the secondary voltage, so we easily calculate the ratio of primary turns to secondary turns. The law of conservation of energy states that the total energy of an isolated system remains constant. It is said to be conserved over time. The ideal transformer doesn't consume energy, so the energy in the primary is equal to the secondary. First, calculate the total power on the secondary side. Each globe consumes 20 W and 6 globes consume 120 volts. This power is also the power on the primary coil. Second, calculate the current on the primary coil. The power is the product of voltage and current. Solve the current from the power equation and substitute the value of power and voltage into this equation, then the value of current is acquired. Transformers need a changing magnetic flux to operate. Only AC will provide a changing flux. DC will produce a constant flux and the transformer will not work. This is a DC generator. The direction of rotation is clockwise. The field is parallel to the plane of the loop and therefore there is no field through the loop. As the loop rotates there is no change in flux and, as a result, there is no EMF. Rotating the magnets around a stationary loop also produces EMF. If magnets are rotated by 90 degrees, EMF is produced. High-voltage transmission lines are used to transport electrical energy. The voltage at the power plant is 500 kV, and the current in the transmission lines is 700 A. The power plant provides 350 megawatts, and 20 megawatts is lost. Using Ohm's law and power equation, students calculate the resistance of two transmission lines. Using Ohm's law, we can calculate the voltage drop across the lines. This voltage drop is subtracted from the total voltage. We find that the voltage delivered is less than the voltage required by the town. Or, we can calculate the power delivered by lines and the voltage that attains the town. We also find that the voltage is less than the voltage required by this town. The power delivery and resistance are constant. If the transmitted voltage is decreased 10 times from 500 kV to 50 kV, the current would increase by 10. According to the power equation, the power loss would increase by a fact of square 10, 100. So, the less power would be delivered to the town. One multiple choice question has 1 mark, and 3 short answer questions worth 15 marks in this section. The overall score for this section is 16 points. With a total possible score of 130 points, the percentage for the electric field is 12.3% of the total score. If you need my help, please add me on WeChat or WhatsApp, and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel and Lou's VCE Chemistry channel.